So next topic is quantum mechanical model of atom. It is a new lesson, second lesson. This lesson is similar to atomic structure. So before you studying this lesson, let us recall the earlier concept that you studied in lower classes. So in lower classes, we studied about atom. So atom was first discovered by John Dalton in 18th century. And he made some postulate, and he said atoms are made up of matters. Atoms are made up of matters. And second, he said atoms are indivisible. That means, so atoms cannot be subdivided. So John Dalton said atoms are made up of matters, they are indivisible and cannot be subdivided in the 18th century. But so in 19th century, several scientists proved that so atoms can be subdivided. Atoms can be subdivided. So atoms can be divided into three types. One is you can take proton, electron and neutron. So protons means positive charge, electron negative charge, neutrons means no charge. So based on this, several scientists proposed several atomic models. So some of the models are J.J. Thomson atomic model, Rutherford atomic model, and Bohr's atomic model. So let's see one by one. First we start with J.J. Thomson atomic model. So first with J.J. Thomson model, atomic model. So you conduct an experiment. So it is a cathode ray experiment. So in this experiment, he tells that atom consists of negatively charged particles. Atom consists of negatively charged particles are called as electron. So in the cathode ray experiment, he tells that so atoms consist of negatively charged particles are called as electron. He also tells that so atoms are made up of positive spheres. So atoms are made up of positive sphere in which electrons are embedded. Electrons means negative. So electrons are embedded similar like watermelon. So in watermelon, the red color, fleshy parts are positive and seeds are negative. So then already we know this model is also known as plum pudding model. Plum pudding model. So he tells that atoms consist of positive spheres in which negative electrons are embedded like watermelon. So in watermelon, the red color juicy parts are positive and seeds are negative means it present equal amount. So if positive and negative present in equal amount means definitely there is a possibility for neutrality. So he also explained electrical neutrality of an atom. He also explained electrical neutrality of an atom. So it's all about J.J. Thomson. It has some limitation. So limitation means there is they fail to explain the structure of atom. So fails to explain the structure of atom. So next we will see. Next model is Rutherford atomic model. So this model is done by using gold foil experiment. Using gold foil experiment, and he bombarded thin gold foil. He bombarded thin gold foil with fast moving alpha particles. Bombarding means colliding gold foil with alpha particles. Suppose you take this, so it is in gold foil. So in this, when you pass alpha rays, remember alpha means 2He4. That means it contains 2 protons and 2 electrons. Already we studied in lower classes. Atomic number denotes proton, and proton and electrons are same. So it contains both proton and electron, in which these electrons are removed. So we have only protons alone they consider. Remember, these 2 electrons are removed, only they consider these 2 protons. When you pass this alpha ray through the thin gold foil, and he observed 3 things. So first one is, most of the alpha particles are passed through the foil. So first he observed is, most of the alpha particles are passed through the foil, and second he observed some alpha particles are deflected, slightly deflected. Some alpha particles are slightly deflected, and third, few alpha particles are slightly bounced back. So when the electrons will bounce back. So already he said, so in helium they remove 2 electrons, so only they passing 2 protons. Protons means already we know it is a positive charge. So when the bounce back will occur, only if there is a like charge, that means same charge. So based on this 3 observations, he concluded first observation, most of the alpha particles are passes through the foil. Second, he observed slightly deflection in the alpha particle. Third, few alpha particles are bounced back. Why it is bounced back means only if there is a like charge. Like charge means same charge is there, then only the bounce back will possible. So based on these 3 observations, he concluded that atom has large empty spaces. That's why most of the alpha particles are passes through the foil. Second, he said this is mean tiny positive charge because of the bounce back. So tiny positive charge present at the center. Present at the center is called as nucleus. So nucleus means tiny positive charge present at the center. And third, he said that the size of nucleus, the size, already we know. So tiny positive charge, definitely the size will be very small. So the size of nucleus is smaller than the size of atom. So size of nucleus is smaller than the size of atom. And fourth one is very, very important. He said that nucleus, so a nucleus in which electrons are revolve around the nucleus. If nucleus means it's in which the electrons are revolve around the nucleus are called as orbit. It's called as orbit. So he said that, so electrons are revolve around the nucleus are called as orbit. It is an important one. So called as orbit. So based on this postulate observation, he made this conclusion. It has some limitation. So what is its limitation? According to electromagnetic theory. According to electromagnetic theory of radiation, he said that nucleus, electrons are revolve around the nucleus. If the electrons revolve around the nucleus with a high speed means, So at certain stage, it loses its energy. When you revolve around the nucleus with continuous speed means at certain stage it loses its energy. So once it loses its energy means definitely it comes close to the nucleus. So it comes close to the nucleus, finally it falls onto the nucleus. But this does not happen in Rutherford atomic model. So even though it is not happening, but it has two limitations. One is, he failed to explain the stability of an atom. He failed to explain the stability of an atom. And another limitation, this one is important limitation, he failed to explain the distribution of electrons around the nucleus. So he failed to explain the distribution of electrons around the nucleus. This one is an important limitation. So based on the limitation only next atomic model will come. So this limitation is overcome by Bohr's atomic model. So next topic you will see Bohr's atomic model. This is all about J.J. Thomson and Rutherford atomic model.